Bonjour, welcome everyone, and thanks for staying around for the last talk. Intents, they are literally the starting point of every Android application. At the same time, basically, if you take something like the traditional stride model, at least 5 out of the 6 threat categories you can fall into with potential attacks. So don't let attackers exploit your apps via intents. I'm Balázs Gerlei. I'm a senior software engineer at Nevis Security, and I'm sorry for using a picture I took in a tent as the cover image for the talk. Okay, I want to talk about different exploits using intents. I want to focus on the mitigation side, but I really don't want to encourage anyone to exploit other apps. But it's important to understand the attack surface, so I'm going to talk about the attacks as well. But first, I work at Nevis Security. We are basically working on the CIM, customer identity and access management space. We are having different kind of security-sensitive customers. Fun fact is basically we are protecting over 80% of all the e-banking transactions in Switzerland. I'm from Hungary, Budapest, where we also have an office other than Germany, Switzerland, and UK. Okay, so I know this is Android 101, but let's get on the same page. So I will quickly talk about intents and intent filters. Intents basically the primary inter-process communication on Android. There are 3 fundamental use cases. You start an activity, start a service, or deliver a broadcast. When you start an activity, it can be for a result as well. And there are 2 main types, being explicit intent, when you specify the target component, and implicit intents, where you don't specify the target components, that just the action that you want to perform. Now, these intents basically work like in Android. They can be used for communication within your application, but also between different applications. This is fundamentally how Android is built, different components on different applications achieving a certain task. Now, the other side of it is intent filters. They are the receiver end, where you can specify what kind of actions your application or your component can basically act upon. You can specify the category, action, data, and some metadata on that. It's important to know already that intent filters and intents are not matched one-to-one. I will talk about that, so remember it. Okay, now the special kind of intent, or basically a wraparound intents, are pending intents. Basically, that's set up to be launched at a later point. So you have an intent wrapped in the pending intent. The canonical example, I would say, is the notifications, when there's a pending intent inside the notification, which will be used when the user taps the notification. It allows apps to take action on behalf of another application using that app's identity, basically permissions and permissions. So let's see the attacks, what you can do. First one is a very simple one, intent denial of service. So you can basically block the usage of the real application. And let's actually show it first without not just talking about it. So I have a demo target application. This is an imaginary investment firm called Victoria and Timothy, or Victim for short. I'm a father, I'm allowed to use that jokes, I think. So, and then see the simple attack of sending an intent with a null action in it, which will crash the target application. What happens here is you can see on the left side that the intent doesn't have any action. Honestly, I'm not sure what's the intended use case for this, an intent without an action, but you may assume that an intent must have an action. But if you do that on the victim side, you can see how it's crashing the application. It's pretty hard to do this in Kotlin because you have to force and wrap. On Java, it's a little bit easier, but it can be done. Now, a little bit more sophisticated than this is to not use null objects, but actually put a custom serializable class wrapped into the intent, expecting or seeing that the target application tries to get that serializable intent out. And to show this, I actually have a demo, or not really a demo, but really a useful tool that I took over the development of. It's called Intent Fuzzer. It's basically an old pentester tool, but it was kind of abandoned. It was targeting like Android 4.4 or something like that, so it was even hard to run on a modern Android. I barely modernized it, but you can use it already for testing your own applications. So you can see the attacker application, and if I long press on it, it will crash as before. So what happens here is very simple form of denial of service. Basically, if the attacker or target application expects something in the intent, it cannot just be the action. It can be something else as well, to be non-null, and you send a malformed intent just to crash the application, or put a serializable extra in it, seeing that the target application tries to get it out and parse it. Now, depending on your threat model, this might not be a problem, and this will be basically relevant for all of the exploits I'm talking about. So I know you have a calculator or a game application, maybe it doesn't matter whether your app is crashing or not by a malicious application, but imagine, for example, a banking application where the denial of service can mean that the user cannot see a transaction that's happening. Okay. This is the intent fuzzer application I was talking about. You can use it already to test your own applications. Okay. What you can do to mitigate. Basically, intents are inputs, at least the ones that are coming into your applications. And inputs needs to be sanitized. So that's what you should do. Basically check for unexpected actions, extras, etc. Handle the exceptions during the parsing. I can show you as well in the victim application. What we are doing basically, why we are crashing is in the onCreate, we have this try parsing intent. And if you look at it, we will go through the different intents, or different extras embedded into the intents. And the custom serializable class crashes here when you try to get that extra out. And the simple try catch basically solves the issue. So if I rerun the application here, oh, it still crashes. And why can it be? It's because what we are doing on the malformed intent when we found it, we call finish activity. Now, you can do different kind of things depending on your architecture, but this can be a real thing. But the gotcha here is that between Android 9 and 12, Android, for some reason, tries to still access that serializable class inside, so it will still crash with that same class not found exception. What you can do is to replace the extras of the intent you got with an empty bundle, and then it will really solve the issue. And I only found this by experiments or experimentation. See, the app doesn't crash anymore. It runs still in the background. Also, you can use a nice class called intent sanitizer. It's part of AndroidX.core. Basically there, it has a nice builder. You can specify what kind of intents you expect. Basically, it's an allow list, which is quite important in security every time. So use an allow list, not a block list. Specify what you allow to go through, and at the end, after the build call, you say what to do when there's an unexpected intent. You can sanitize by throwing and sanitize by filtering. So I can uncomment this line, which calls basically this. Here's where the builder is set up. It's basically set up in this example to only accept the launcher intent, so extra main and category launcher. And at the end, I call sanitize by throwing, which will throw an exception. But you can call sanitize by filtering, which will return a new intent, a sanitized intent, removing everything else that's unexpected that you don't want to handle. Okay. So you can basically rely on this if you think about it. We can remove the try catch, right? Sanitize the intent and then try parsing it. The problem here is that it's not really a bug, I would say, while it's loading, but it will still crash because the sanitizer itself, if it encounters an unknown serializable class, custom serializable class that's only known by the attacker, it will still crash. It will have the same exception. I don't think it's a bug per se, but maybe you need to be aware of that and still use a try-catch in it. Or you can, of course, use the other one as well to directly use the result of the sanitized intent. Okay. A little bit more serious. Intent redirection. Basically what it means is that an attacker fully or partially controls the content of the intent that gets launched inside another application, so in the context of the target application or victim application. This easily leads to elevation of privileges. Basically, you can launch even an unexported component. I will actually show this as well. Let's get back to this demo malicious application, which can use an embedded intent to launch this. Oh yeah, the sanitizer crashes, of course. So like this without the... So you can launch something that's not supposed to be launchable from outside. Here it does nothing basically, but if I go to the manifest, you will see that this is the private activity that has exported false. Now what happens here is that our victim application, for some reason, you could have seen it already before, it tries to find an embedded intent inside the intent it gets from the outside. And if it finds it and it's an intent, then it calls start activity with it. Again, I'm not entirely sure about the intended use case of this, but maybe some system applications doing that, or how to basically launch something upon a broadcast or something. Most commonly, the intent is embedded in the extras field, as I showed you in the example. Now, what you can do with the mitigation side, you can also sanitize intent as before. Basically, don't allow this if you don't expect it, or don't allow it from just allow it from the known other component that you want to provide the functionality, and carefully implement the parsing logic. That's also quite important. Don't launch intents that are embedded into intents from outside if possible. It's already quite dangerous. Or use immutable pending intents. Yeah, I forgot to mention that since Android 12, the immutability needs to be explicitly set for pending intent, which is quite important. That's one of the reasons. And try to use immutable intents that they cannot be modified. Okay, there's something related to this. I couldn't find a smaller, shorter name for it. Explicit intents that partially matching the intent filters. That's what I alluded to, that intents and intent filters are not matched one by one. And what I mean is that when you have an explicit intent, meaning that you specify the target component which should handle it, the other configurations doesn't need to match the intent filter. The common mistake here is that if you have a public and a private receiver with a different intent filters, let me actually show you that. It's easier. So I have these two receivers. One is the external receiver that's supposed to be accessible from the outside. It's exported through, and it has an intent filter with an action, public external action. And you also have an internal receiver, which is not exported. It's not supposed to be accessible from the outside, and it's really not. But it has this private internal action, and you might assume that you cannot send the private internal action to the external receiver, right? But no, you can. And it gets received as well. So even though it goes into this receiver, the public one, if you do something like this to remove code duplication, to handle the logic in a centralized place, like this centralized intent handler in this example, and then you decide based on the action what to do, you can come through the external receiver, but with the private internal action, and you can still access basically that functionality that's not supposed to be accessible from the outside. Basically, the end result is the same, so I won't show it now. I put this on the slides as well for posterity, but I showed you in the real application. Again, the two receivers with the centralized logic handles it, and the switch. Okay, what to do? Luckily, it will be fully mitigated in Android 16, so if you try to do this on a new Android 16 device, then it will fail with an exception. And you should, even before that, you should separate the logic fully between different intent receivers and don't rely on the intent filters doing the work for you. And you can also use intent sanitizer here to an extent. Maybe I can, let's not do it. Let's not show it, but on Android 16 device, you get an exception when you do this, basically, by default. Okay. Doing something even more interesting, as even this depends on your threat model again, the previous attack. Now let's go to the other side. So intents are not just inputs, as I said before. It's also outputs. You can send your intents, and those can be hijacked as well. What I mean is that a malicious application can define its intent filter in a way that it gets your intent, or maybe there will be a chooser that the user can choose which app will handle that intent. It's especially a problem it's a problem if you don't fully specify the target component, so it's not an explicit intent. But let's imagine a use case when you want to pick an image, for example. We can even modify our nice victim application to mimic that functionality. Let's say we allow the user to choose an image, an avatar, for example. And for that, we decide to send an intent. So something will handle it. We send an action pick intent with the type image data. And when the user taps it, they can choose between a real application, in this case photos, and the malicious application, which is in this case called taskjack. And if the user is tricked into choosing this, and at this point I have to mention that some form of social engineering is required in these situations, at the very least you need to convince the user to install your malicious applications, and also in this case you need to convince the user that your application really provides the functionality. But it can be done. You can also provide the benign functionality of the malicious application in a normal situation, convincing the user that it's a real application. So if the user chooses the malicious application, it can, instead of picking an image, can throw up the same login form. I showed a red button to signal that this is the malicious application, in this case, not the real one, but the interface looks the same. But what it does is when you log in, it tries to steals the credentials. Okay, it might be non-realistic for the user to immediately show or see login like this, but you can still, I think you can still think that you can imagine that the user can be tricked, like throwing up a toast that the session expired or something like that. But the malicious application can be more tricky. Instead of immediately showing the prompt, it can return to the call application in this simple example, or in a real-world scenario, it can return the photo, or I was lazy to code that, but it can be a real picker in disguise, and then the user thinks that it achieved its functionality. See, it returns to the call application. This is the real one, but after a delay, the attacker application can still throw up its own activity on top of the other one, and I will talk about tasks in a moment and backstacks, but the end result is the same. But it's more convincing for the user. Again, imagine throwing up a toast that the session expired or something. Okay. Apart from that, I only showed you one of the problems of basically spoofing, but it can also be that the attacker accesses sensitive data from the intent that it hijacks. So it can be information disclosure as well. And performing arbitrary actions, launching components, or modifying a mutable pending intent. And here I showed that the mutability needs to be explicitly set if you target Android 12 or newer. What can you do? Specify the target component when making the intent explicit. Narrow down the target at least if you really have to use implicit intent. And really don't put sensitive data into implicit intents. That's core. Always use immutable pending intents. And actually you can use a nice photo picker component to pick media from Android X.activity library. It's really nice. Basically, if I modify the victim application, I can show you as well. The demo is in Compose, but you can do the same in the Vue system as well. But it's really, really simple. So you basically, in Compose, you use this remember launcher for activity result, where you get the result back. And to launch, the picker is basically one line here. And then all the application, when it happens, is basically the default file manager application will be always used. Not anything that can handle. But on a newer Android version like this Pixel 7, I have here with Android 16. If I use that, there will be an UI inside your application, like this. So this really solves a common use case that can lead into a problem. But of course, other intents can be still hijacked. Okay, now hijacking is not only affecting intents, it affects tasks as well. I already alluded to it a little bit, but to understand that, let's talk a little bit about tasks and backstack. Tasks are basically just a stack of activities. There's a root activity that is launched when the task is launched, and the backstack is basically the history of the activities that the user can navigate back to in really short terms. I'm sure that you're familiar with that, but just to show you, when the task gets launched, when an application gets launched, basically a root activity is put into its task. If you navigate forward, more and more activities are put into the same task if you use multiple activities, which you shouldn't, but I'll get back to that. And if the user navigates back, then the activity is popped off the top If another app is launched or your application has multiple tasks, then that task gets to the top of it. And if you look at this image, you might even remember that this basically mimics this one, the task switcher or recent applications, how it's called. It's good to know that many users expect that these are different applications. Basically, I think they remember how it's done in the PC world or the desktop computers, but in Android it's not always different applications. Remember that. Okay, let's talk about StrandHogg, which is about hijacking the task. But first, show your hands if you heard about StrandHogg before, please. Okay, not many, like 3, so it would be interesting. Well, basically, it's a static attack. It's based on malicious applications, specifically targeting a victim application. It needs to target it in manifest, so it relies on static configuration, which means it can be found via static analysis as well, and it should not go through Play Store anymore. What it can be used for is privilege escalation, basically asking permissions that the user would grant to the target application, but might not grant for the malicious application or the malicious application. And it can also be used for the same as before, the app impersonation or spoofing phishing credentials. What will happen is basically, and this is true for even privileged system applications as well, don't be too afraid, it's already fixed in Android, but first let's talk about the attack. So basically what happens is that the user taps the real launcher icon of the victim application, but in reality the malicious application gets launched. I will show you. The trick here is that you need to convince the user to launch the attacker application first. It can have benign functionality, like in this case, greeting you. But afterwards, this is the exploit is triggered. Then, when the user clicks, and I clicked on the real victim application, what gets launched, and you can see it from the red button, is the malicious application. Which in this case steals the credentials, but you can imagine user trying to launch the phone application and then call log access permission coming up. So it's quite serious. The user may not even know that they fell victim. As I said, the user needs to launch the malicious app first. What really happens here is that when the malicious activity gets launched, this is when it's triggered, it basically creates the task and puts its activity in it. Then the user tries to launch the app that they need, the victim, but because the two tasks, the malicious one's task and the victim's task, have the same task affinity, then the malicious activity is brought to the foreground because it's running in the background, and Android brings back the other task. The key here is the configuration is in manifest. The task affinity, I don't know if you know that, but if you don't even specify it, it gets defaulted to the application ID of your application. So, and it's a free-form text field, so any application can define anything there. They can just define the same as your application is, and then Android will treat that two applications logically belong to the same task. Other one is the allow task reparenting, which is a flag that means that your activity is allowed to be put to another task, and you can hide your attack with the exclude from recents flag, which just means that basically the malicious app is not shown in the task feature or recent screen, just the user that doesn't know that it's already running. Mitigations. As I said, it's fixed, fortunately, but it's not that long ago, I would say. So Android 11 fully fixed this. So if you run on older Androids, then your app is affected. But you can do fixes, luckily quite simple. You can specify an empty task affinity for your component, for your activities, and it's much easier with a single activity. That's why I already alluded to that. I highly recommend using a single activity because it's much easier to control the attack surface. Or you can also specify a single instance launch mode for your application, but be aware that this can result in broken user experience, because that really means that that activity is the only one that's allowed to be launched into your tasks. And if you really interact with other applications, then it can break the user's expectation that you share something, and if the user checks the recent screen, it will appear as two applications, or at least that's what they may get from it. Now, from the name, the StrandHogg 1, you might already guess that there's another one. It's called StrandHogg 2, and it's even more serious than the first one. problem with StrandHogg 2 is that it's fully dynamic, so it doesn't require static configuration in the manifest as the first variant, so it's much easier to detect, or sorry, much harder to detect. It's basically implemented in code, which code could be basically loaded dynamically as well, or the list of target applications can be loaded dynamically as well, for example, from the network. And I used the plural form because there are multiple applications can be targeted with this attack. It's not a single target as StrandHogg 1. Basically, you can also, if you have, I think the name of it is query all packages, the permission that grants you querying the applications that's installed on the device. So if your attacker application has that as well, then you can even check what applications are installed on the device from the target list and then target them, because there will be a priming step as well. It can be used for the same goals. So basically, elevation of privileges via permissions or spoofing credentials phishing. The problem here is that it's relatively easy to implement, but hard to detect and mitigate. The user, again, may not even know that they fell victim, and how it looks like is really, really similar. So if I remove the first attacker, and I will show the launching the victim app because, again, in this case, you don't need to have the attacker launched first. It needs to be running in the background, but it can be that it launched after the victim application. We defaulted back to the other device, sorry. Yeah, so we have the victim application being running. And now I launch the attacker application, which can, again, provide some benign functionality. And I can even switch back to from the recent screen to the victim application, and it will still work. It will still work the same as if I launched it from the launcher screen. Now, this is an old emulator Android 9. Keep in mind. Basically, what happens here is that 3 intents get launched. Maybe let me show you again. So when it's triggered, when the attacker application is launched, it launches 3 intents in the same single call. It launches the victim activity in a task, then puts its own malicious activity on top of it in the same task, and then it launches another task with the distraction activity, the benign functionality. And then when the user tries to switch back to the victim application, the benign functionality and this task goes away, and you go back to the setup task with the malicious activity on top. The key here is launching 3 intents. The first one launches the target activity of the victim. It needs to have the flag activity new task, creating explicitly a new task. Then the second one is the malicious one. This is that puts the malicious activity on top of the victims. The key here is that you don't need any special flag like the flag new task. And the third one is the distraction activity, the benign functionality, which also needs to have the flag activity new task to create a new task explicitly. There's some additional steps here, but I don't want to show that. I'm not want to encourage the attack as well, but it's not hard to figure out. You need to pass these 3 intents to the same start activities call, and you can even disable animations so that the user sees that just the benign functionality comes into the background, in the foreground, but in reality 3 intents gets launched. Mitigations. This is again mitigated in Android 10, and it's so serious that the fix is backported to Android 8, 8.1, and 9 via the May 2020 security update. But keep in mind the emulators doesn't have the security update, so it's nice to use for testing this. You can luckily still protect your applications, but the only protection, at least I know, is the single instance launch mode. And as I said, it has some caveats because it can result in a broken user experience. So you might not be able to do this, but if you have a security-sensitive application, and you don't have to share things with the messaging applications, things like that, you may be able to not interact with other applications, and then you can specify the single instance, meaning your activity is the only one that's allowed to be launched into your task. Technically, you can also keep track of the number of activities that gets launched, but I don't think it's really hard to implement. It's error prone, can even have false positive or miss the actual attack, so I don't think it's a good mitigation. Okay, how recent applications recent Android versions can help, because there are some great advances in the last couple of Android versions, Android 15 and 16 especially, but even from Android 10, there's these background activity launch restrictions, which means that basically it restricts the launch of activities from other components that are in the background, so broadcast receivers and things that are in the task. But there are certain conditions. I don't want to put it all of them onto the slide, but there is a couple of them. So app has a visible window in the foreground, and the second one is that I really want to focus on. The app has an activity in the backstack of the foreground task. So basically, this is the case in what I showed earlier with the photo picker example. The user can be tricked to pick a photo from the malicious application, and when it returns, its activity is still in the background. So the example I showed you, after a delay, it launches its malicious credential stealer on top, can still work with the background activity launch restrictions, at least as of now. Now, remember that. Now, Android 15 and Android 16. In Android 15, we have secured background activity launches, BAL in short, which is luckily also the name of left in Hungarian, so it's easy to remember. It means that you don't bring the task back to the foreground when launching activities from the background. Also, pending intent creators are blocked from background activity launches by default, but you can opt into it. Now, what I really want to talk about is safer intent, but it might not be clear. I think it only appeared in a single video from Google I/O that it's not enforced at the moment to ease adoption. And also, there's supposed to be this wonderful thing, preventing launching activities from other apps into your own task, but I will talk about why it's crossed out in a moment. Now, Android 16 has default security against general intent redirection attack. That's the thing that I showed before. Basically, when you have an embedded intent and you try to launch it, it will be blocked. I also mentioned already. And apps will be able to enforce the safer intent restrictions from Android 15. In Android 15, what you can do is to enable strict mode. I can show that as well. So basically, you can force the thing upon yourself. Like this strict mode set VM policy and detect unsafe intent launches. That's what in Android 15. And it can have penalty deaths and penalty log. But you can use this as some form of protection as well. Like if you apply this to your own application and say penalty deaths, like you will crash then. It's denial of service still, but you can at least avoid launching something that is unsafe in your application. Okay, now safer intents, what they mean. Basically, intents must have non-null actions from now. And the other rule is that explicit intent, remember, that's the one that you specify the target component, so they must match the target component's intent filter. Basically, to mitigate the thing that I showed you with the different receivers, the one private and the one public, with the action not matching, so mismatched action. Now it will be not allowed. As I said, it's not enforced, but apps targeting Android 16 can specify these intent matching flags in the manifest with 3 values which can be combined. None is basically the previous behavior, no other stricter rules, but there's this enforce intent filter, which is the one that explicit intent should still match the intent filter, and also the null action is not allowed. If you combine this with allow null action, you still allow the null action, but you have to match the intent filter. So this is how you can configure this from Android 16. And now the funny thing or the interesting thing is the prevent launching activities from other apps in your own task. And naming is hard, so it's called allow cross UID activity switch from below, just rolls off your tongue. It's disabled by default, but you can allow it even in a per activity basis. The trick here is that both apps need to target the new Android version, and you will see why I don't say about Android version. So both apps need to target the Android version, the attacker and the victim as well. So the one in the foreground and the one in the background. But it will actually prevent the case that I showed you when the application gets into the task, which, by the way, it cannot forcibly do so since it's StrandHogg prevention, but if they trick the user to get into the task, like with the picker example, but you can do other way around as well. Like you have a game application, and the game application has a sharing functionality and shares the victim application, then you can still get into the backstack. So in this case, this will prevent launching activities from the background. The problem is, or unfortunately, this has been pulled from Android 15 at the last minute, and it's not in Android 16 as of now yet, due to the many bugs reported, because as you can imagine, this is a functionality for so long in Android that many applications supposedly rely on this. But I heard that it's coming back, so it's work in progress, but hopefully it will come back. And again, I would like to get back to the threat model, because this might not affect your application, but if you are in a certain use case, this might be important for you. Okay, we reached the main takeaways already, so I'd like to emphasize again that inputs, intents that are coming into your application are inputs, and inputs need to be sanitized. So you need to use an allow list, not a block list. So basically only say what you allow. Use the intent sanitizer if you want. Be aware of the custom serializable class, that it will still crash your application. And I cannot emphasize enough that you should do threat modeling. It's not a talk about threat modeling, but basically threat modeling is, you can use a diagram to show the border switches of trust levels, so different trust levels, your applications in the middle, and showing the trust level changes. And for each border crossings, like the intents coming into your application or the intents coming out from the application, you think about what kind of threats can be on that attack surface and what kind of mitigations you have for each of them. And you can decide that some kind of attacks are not relevant to your application, like the denial of service if you are not a serious security-sensitive application. Also, I would highly recommend simplifying the activity usage. If possible, using a single activity. I'm a big proponent of using a single activity, not just from the security perspective, but it gives you much easier. Basically, it makes your developer life much easier. I don't know if you have, for example, had to differentiate between the application lifecycle and the activity lifecycle, and with the asynchronous events, it's really hard. So if you have a single activity, it gets much easier, and then you can be more restrictive of the launch modes of that single activity. Set an empty task affinity, don't rely on the default to mitigate for StrandHogg 1, and use restrictive launch mode if possible, preferably the single instance one. Of course, then you block out any interactions with other applications, but that's the downside of it. Okay, I would like to thank for your attention. The first link leads to my speaker deck, where this slide will be put up. And I would like to highlight the Android security evolution, which is basically a list I maintain. I will show you here. This is a list I maintain about certain security features that's only available from a certain Android version. So it's a good talking point or cannon fodder or something. It has things like the StrandHogg there. Basically a good idea or a good resource to decide the minimum SDK that you want to use. Because for example, with the background activity, allow cross-UID activities which from below, basically you only can rely, when this gets released, you still can only rely on it when the minimum allowable Android that is installable, minimum target SDK that's installable on Android version is the minimum that you allow your application to run on. Because otherwise, you know, the target or the attacker application can specify another target SDK and be exempt. So that, oh. So the one I would like to highlight is that even from 2015, the first talk I found about task hijacking, so it's not a new thing by any means, but it's still relevant. I would watch it even though it's a bit outdated. And the last one is the Hacktricks ebook, which I really like. It's a good resource for pen testing. And yeah, and with that, thanks. Merci.